How would your life change if things could happen hundreds of times faster? If the wait went away? Maybe you'd have lunch in Paris, see a show on Broadway, have dinner in Beijing, and still be back in your own bed by 11. What if your storage device were that much faster? You could unleash the power of your processor instead of it working at a fraction of its potential like today. Eliminating that bottleneck requires better storage memory that is fast, inexpensive, and non-volatile, so your data doesn't go away when your power does. DRAM memory is great because it's very fast, but it's also very expensive and it's volatile. And unlike many silicon components, DRAM density isn't doubling every 2 years, so it's hitting a wall. On the other hand, NAND memory found in today's SSDs is both inexpensive and non-volatile. And while it's lightning fast compared to other storage technologies, up to 1,300 times faster than hard drives, it's still about 1,500 times slower than DRAM. But get ready, we're about to shatter today's rules in a very big way, thanks to some breakthrough engineering we've been working on. Soon, for the first time ever, we'll be able to equip computers with memory that's fast and inexpensive and non-volatile. Intel engineers have helped design a next-generation non-volatile memory called 3D XPoint, something many experts said was impossible. And this new technology isn't just twice as fast or even 10 times faster than NAND. It's up to 1,000 times faster. So how'd we do it? To make 3D XPoint inexpensive, we needed to pack lots of capacity into a tiny footprint. We started by slicing submicroscopic layers of materials into columns, each containing a memory cell and selector. Then, we connected those columns using an innovative crosspoint structure consisting of perpendicular wires that enables memory cells to be individually addressed by selecting one wire on top and another at the bottom. We can stack these memory grids three-dimensionally to maximize density. And whereas DRAM requires a transistor at each memory cell to access or modify the cell, making DRAM big and expensive, each 3D XPoint memory cell can be written to or read by simply varying the voltage sent to its selector, completely eliminating the need for transistors. This simple, stackable, transistorless design enables 3D XPoint to pack up to 10 times more capacity than DRAM in the same space, greatly reducing cost. When it comes to memory performance, low latency is the key. Whereas NAND latency is measured in tens of microseconds, 3D XPoint technology's latency is measured in tens of nanoseconds, a tiny fraction of NAND's wait time. This makes 3D XPoint ideal for high-performance SSD storage, delivering up to 10 times the performance of NAND across a PCIe NVMe interface. Plus, 3D XPoint technology's lifespan is not significantly impacted by how many write cycles it can endure, which means it can simultaneously serve as a single, high-speed, high-capacity pool of system and storage memory. There you have it, a truly disruptive memory technology that's fast, inexpensive, and non-volatile. Get ready to unleash your processor's true potential and realize possibilities we thought were decades away. So be sure to stay tuned for upcoming announcements on 3D XPoint technology.